Hi, hello and welcome. My name is Terry. In this video, I'm going to discuss the Additional Mathematics Form 5 Textbook Chapter 3 question, Summative exercise. If you enjoyed this video, please kindly like. And if you'd like to receive more notification on our upcoming video, click subscribe. And of course, if you have any question, you can comment and let us know how we can improve this video presentation. All right, let's get straight to this. Now, the first thing is we are supposed to find, in question 1, we're supposed to find indefinite integral for the following. So I think we have to expand first because we can't integrate in this form. So let's expand the bracket. This will be x squared plus x minus 6 dx. I hope we can expand very quickly. This is x squared plus 3x minus 2x plus 3 minus 2 is plus 1. Minus 2 times 3 is minus 6. So the next thing is we should just expand this x inside, multiply inside 1 by 1, you get x power 3 plus x power 2 minus 6x dx. Now when you integrate this, you should get x power 4 over 4. This should be x power 3 over 3. Now when you integrate 6x, I'd like you guys to think x squared 6 divided by 2, 3. In your mind, you should be thinking this way, so you just cancel it 3. So you don't have to write extra step, otherwise you have to write one more line for every single integral, right? So that's it. That is the answer for part A. Now for B, we have to use composite function. Now the one that I've always taught my student is this, using this shortcut formula. When you have the bracket below, you put a negative in front, you copy k, you copy ax plus b, reduce the power by 1, put the reduced power in front and differentiate inside the bracket. This is much faster than bringing the bracket up, integrate and bring it back down. So if you want to integrate this, let's put a negative here. Let's take copy 2x minus 3, reduce the power by 1, you get 2, put the reduced power 2 in front. As we have 2x here, differentiate 2x, you get 2, put below here, and of course you have to put a plus c. And from here we can simplify further. We can cancel 2 and 2, you get negative 1 over 2 with the 2x minus 3 power 2 plus c. Okay, it's not difficult, right? All right, let's move on. Let's look at question number 3. Okay, now if you were to find the value of unknown, we still have to integrate first, but notice this time they actually write in the form of power negative. So what I'll prefer to do is, in this case I have no choice but to bring it up. So since I know my final answer will be in the form of power negative, so I'll just bring it up first. Alright, so when you integrate, you copy the bracket, you increase the power by 1. Remember the difference between the bracket when the bracket is on top and the bracket is below is the power. When the bracket is below, we reduce the power. When the bracket is on top like this, this is a general form. You increase the power by 1, you divide by the increased power, and you differentiate inside the bracket. Also, we have to differentiate inside. Okay, so then I've increased the power by 1 minus n plus 1, then divide by the increased power minus n plus 1. All right, and then you differentiate inside the bracket. Now inside the bracket you have 3, and let us just rewrite this. Maybe I write in front here, of course you have to put a plus c here. I put 2 over 3 1 minus n. I'll just separate this 3x minus 2 with the 1 minus n, or you can write 1 minus n plus 1 plus c. You want to compare with a 3x minus 2 power minus 2 plus c. That's what we have above here. So let's start by comparing your n, the power. 1 minus n is minus 2. Bring it over, bring over, n is just 3. If you compare the coefficient, that means you're comparing the number in front here. Let me just highlight for you this one and this. We're comparing the coefficient of your bracket here. So your a is 2 over 3, 1 minus n. Since n is 3, so 1 minus 3 is negative 2. You cancel them, you get negative 1 over 3. All right, Okay, I still need to do part B here, so I think I have to erase this to have more space. I'm going to do part B on the right hand side here. So the first thing is, they say use the value of tan here to find the integral of this. Okay, now look at this and compare. So basically now my n is now, you're finding the value of n, right? Can you see? And this is 2, this is 8. So I need to use a result, right? Now we know that 1 to 3, 8. Okay, maybe I write this down first. Write this down first. We know that to go to 8, I have to, the 2 I have to times 4. To go from 8 back to 2, I have to factorize it. So you take out 4, 1 to 3. This will be 2 of 3x minus 2 power n dx, right? And from here, okay, the question says using the value of n. Oh, sorry. That means my n is 3, right? My n is 3. So we are going to use this information. We know the result integrating this is going to be this, right? Since my a is negative 1 over 3, so this will be 4 times negative 1 over 3, right? And you should have 3x minus 2, and there's a power negative 2 here. Let's forget about the plus c. I'll just put the bracket like this, right? 1 to 3. I think we can just cancel, put it together, negative 4 over 3. Bring this bracket down. It's easier to see, yeah, if it's in this form. So this is power 2, lower limit 1, upper limit 3. Now let us put 3 inside. So 3 times 3 is 9. Yeah, imagine this, I'm putting 3 inside here. 3 times 3 is 9. 9 minus 2 is 7. 7 squared is 49. Now if you can't do it, you can write like this, but I'm not a big fan of this, because I think the more you write, the more difficult it is. So I would like to just think 7 squared, 49, right? So this will be 3 minus 2, 1. 1 squared is still 1. So it's minus 1 over 1. So it's negative 48 over 49. And 48 over 49, you can cancel it. You can just use your calculator if you cannot do it mentally. You can cancel it. You get 16. 16 times 4. 48 divided by 3 is 16. 16 times 4 is 64 over 49. And this positive value, or you can write as mixed number 1, 15 over 49. Okay, I think this is not difficult. All right, so let's look at question number 3. So in this question, yeah, the thing that makes it difficult is that you have to use differentiation of quotient rule, using quotient rule, and of course you have to simplify it. Then use the result to find the integration of this. Okay, number 1, I hope you already know how to differentiate u over v. So the formula is this. When you differentiate is vu prime minus uv prime over v squared. Yeah, if you can't remember your differentiation, you can watch back the video on differentiation that I posted earlier. So my v is 5x minus 1. Now u prime, as you can see, it involves composite function here. So I have a 3 in front. So the 3 have the times with the power 2. So you get 6, copy 2x plus 1, reduce the power by 1, it will be 1. As we differentiate inside the bracket, you get 2. Then you minus your u, which is 3 2x plus 1 square, and you differentiate your v. My v is 5x plus 1 minus 1. When you differentiate, you get 5, and you divide by v squared. My v again is 5x minus 1 squared. Now here we can actually factorize, but I think a lot of people would find it a bit difficult to factorize directly. Maybe what I will do is I take 6, I times 2 first. 6 times 2 is 12. I copy my 5x minus 1 together with 2x plus 1, and 3 times 5 is 15. I just put it together, 2x plus 1 power 2 divide by 5x minus 1 squared. Now as you can see here, we actually have 2 common factors. My first common factor is 2x plus 1, right? So I can take out 2x plus 1 with the bracket power 1, right? Keep the bracket like this. And the second common factor that we can take out, maybe I'll highlight for you, between 12 and 15, we can take out 3. So yeah, you can take out 3, yeah, but if you don't take it out, it's okay, but you can see from here my final answer has a 3. You can even take out later. So what I have left is a 4 and a 5x minus 1 here, whereas I have 5 and 2x plus 1. Remember, you have taken out the 2x plus 1 from the first expression. Over here, you have taken out here, so you're left with and 12, you've taken out 3, left with 4 or 5x minus 1. The second one, I've taken out this, power 2, you've taken out power 1, left with power 1. 15, you've taken out 3, left with just 5. And my denominator will be 5x minus 1 squared. Always work with this answer, final answer in mind. Now, you can actually simplify this. Okay, this will be 20x minus 4 minus 10x minus 5 and 5x minus 1 squared. So you get 2x plus 1. This will be 10x minus 9. Okay, now I know some of you may be thinking, is it necessary to factorize? Actually, for this case, if you don't factorize, it's still okay. But in the chapter differentiation, we always factorize because we want to find the turning point. And turning point happens when dy dx is 0. So it's easier to factorize. But I know some people may prefer to just expand this whole bracket here directly. You can expand the whole thing, yeah, and then simplify further. You can do that, right? So it's not an issue. So okay, if I were to simplify this, because they say show that it equals to this, so we actually have to expand 2 times 10, 2x times 10x is 2x squared. This will be minus 18 plus 10, which is minus 8, and 1 times negative 9 is negative 9. Yep, I've got this answer. Okay. All right, this is part 1, the first part. The second part, we're going to use the result to integrate this. So okay, I know when I differentiate, maybe I highlight for you, when I differentiate this function y here, I will get this one. So when I integrate, I'm actually getting the reverse. You can see the functions are all the same, they're identical. So there's no need for you to integrate, use any formula for integration. We'll just write integration from 1 to 4, 3 of 20x squared minus 8x minus 9. You divide by 5x minus 1 squared dx, and the result integrating this will be the original function 3 of 2x plus 1 squared with the 5x minus 1. Since you have a limit, we have to write lower limit 1, upper limit 4. If there's no limit, we have to put a plus c. Okay, actually the 3 we can take it out. Okay, now for beginner, if you're not sure, I would suggest you write this, but like I say, I always prefer not to write this because it's, especially when you type in your calculator, the more bracket you have to write or have to type in your calculator, the more complicated it will be. So let's just simplify things. You don't have to write this. Okay, anyhow, but if you want, 4 times 2 is 8, 8 plus 1 is 9. This is a 9 square. Can I just do 81? 9 squares is 81, right? And 5 times 4 is 20. 20 minus 1 is 19. And then this is 2 plus 2 times 1 is 2. 2 plus 1 is 3. 3 squares is 9. 5 times 1 is 5. 5 minus 1 is 4. All right. So I know this number is a bit big. You can just use your calculator, right? No point doing it one by one, right? Mentally. So we just take 4. The answer is 459 over 76. You can verify using your calculator, or you can write as mixed number 63 over 76. All right, that is question number 3. Question number 4, a curve has a gradient function of f prime x. Now gradient function means it's your dy dx actually already differentiated. So the curve passes through 2 points, find the value of r. Okay, one of the common mistake I always encounter by the student is that they tend to think that, let's say for example this curve looks like this, we don't know how it looks like. They tend to think that this point and this point you can, okay, obviously this one looks a bit ugly because I add in the what do you call that, the axis, or maybe I drop the axis. Okay, let me just drop the axis. Okay, now I will just draw for you. A lot of people tend to think that this minus 2, minus 16, 1, 14, and then they go and find the gradient using 14 minus minus 16, 1 minus minus 2. Now this is a crime, this is illegal, this is wrong, because this is the gradient of this straight line. It doesn't represent the gradient of the curve. Now the curve has a gradient at this point and another gradient at this point. The blue line represents the gradient of tangent at the curve. Now we know a curve has a gradient that is ever changing. A straight line is different. A straight line has a fixed gradient. Anywhere you measure the gradient of this line is always the same, but the curve is not the same. So you can't go and use y2 minus y1, x2 minus x1 and and compare with the gradient. That is wrong. So what you should do is you have to integrate and substitute the point one by one, as in, okay, let me just show you here. First step, to find the curve, let's say the curve, we write fx, or you can write y, doesn't matter, 2x squared plus 5x minus r dx. So when I integrate, I get 2x cubed over 3 plus 5x squared over 2 rx plus c. Now notice we have two unknown, r is one, c is another. When you have two unknown, naturally we need two equations to be able to solve for the unknown. Yeah, so what we do is we sub the first coordinate 1 and 14, because fx is the same as your y. Your y value is now 14 when your x value is now 1. Okay, 1 power 3 is 1, so I don't want to write 1 power 2 is still 1 when I substitute. R times 1 is just r. Okay, now this number is a bit ugly. If you don't like to use fraction, we just multiply by 6. 14 times 6, 84. 6 times 2 over 3, it will be 4. 5 times 6, 30, divided by 2, 15, times 6r, 6c. Okay, let's just rearrange it. How you want to do it, arrange it, it's up to you. Maybe I put 6c minus 6r, 84 minus 4, 80, 80 minus 15 is 65. I'll leave it as equation 1. Now my second equation is minus 2 minus 16. My y or fx is negative 16. My x is minus 2. Okay, minus 2. Now I'm going to sub inside here, do mentally. Minus 2 power 3 minus 8. Okay, no, I don't write minus 2 cube. And negative 2 I sub inside here. Negative 2 square is now 4. And this is just minus 2. Alright. Plus c. Again, I don't like fraction. We can multiply by 6. Should I multiply by 3? Multiply by 3 will do. Okay, multiply by 3 will do, because this one you can cancel. Notice that this one you can cancel. Left with 2. So I don't multiply by 6, multiply by 2. By 3 will do. So this is negative 48, negative 16, 10 times 3, 30. And this will be 6r and 3c. Right. Okay, so let's rearrange it. Alright, so 6r plus 3c, this will be 14, bring over 62. Now you can choose to get rid of r or get rid of c. Actually, by right, we don't need c, we need r actually, but it's okay. Since I rearranged in this form, you can see that this two has the same term, right? Same coefficient, one is positive, one is negative. So I'll take equation 1 plus 2, 6c plus 3c is 9c, 65 minus 62 is 3, c is, this is 3. Okay, it's a bit ugly, let me just fix it. So c is just 1 over 3. When you sub inside any equation, maybe equation number 2, 6r plus 3 of 1 over 3 is negative 62. 6r is negative 63. 1 over 3 times 3 is 1. So bring over negative 63, negative 21 over 2. Okay, not that difficult. All right. Okay, let's look at number 5. Question 5 here. So we have two integral here. You're supposed to find the value of integration 0 to fx dx minus 4 to 2 fxx. Okay, here we can use what we call the laws of definite integral. You know that when I integrate, let's say, a to b fx dx, it is the same as negative b to a fx dx. So I'm going to apply this formula for the second integral here. So you can see this is 4 to 2. So we're going to put a negative in front, so automatically becomes positive 2 to 4 fx dx. Now another formula you need to know is about the laws of definite integral is that a to b fx dx, when you plus with b to c fx dx, you should get a to c fx dx, provided number one, it must be of the same function. Number two, the upper limit here must be the same as the lower limit of the next integral. So we can put this together to, oops, I should use black pen, sorry. This will be 0 to 4 fx dx, and we know 0 to 4 fx dx from here is 4. Okay, next, find the value of v if the integration of 0 to 4 fx dx plus 1 to v gx plus x dx oh, so many terms here, equals to 19. Now, number one, we need to separate this because we know that, okay, 0 to 4 fx dx is not a problem because I already have here, over here is 4. This is 1 to v gx dx plus 1 to v x dx. The result is 19. So this value is 4. 1 to 4 gx dx is also given as 3, so we just add them up. For 1 to v x dx, I just integrate x squared over 2, 1 to v, the result is 19. So I have 7 here, 19 minus 7 is now 12. Let's put v inside. Maybe you take out half. I like to take out this half and put v inside, so I get v squared, put 1 inside, so I get -1. Yeah, we know how to substitute this. So v squared minus 1 is now 24. 12 times 2 is 24. V squared is 25. Square root of 25 is 5. Okay, do you have to put plus minus? Okay, that's a good question. Do you have to put plus minus? Usually v, the upper limit is bigger, but if the question do not mention, so we should write plus minus, yeah. But usually v is a positive value. I mean, not say positive value, it must be more than the limit here usually, but if it's not stated, you can put plus minus. Okay, next, number 6. Okay, here you're given dv dt. Okay, dv dt is given. Okay, I'm supposed to find the volume when t is 5. Okay, so to find v from dv dt is rate of change of your volume. So we have to integrate. Okay, again, I hope you guys know how to integrate this quickly by now. Increase the power by 1, 2, 10 divided by 2, I write 5 here. Integrate 3 is 3t, then you put a plus c. And you are given, when t is 2, the volume is 24, so you put 24 here. And 2 square, I'm going to write 4 here. This is 3 times 2 plus c. So 24 is now at 20 plus 6 is 26. My c, 24 minus 26 is -2. So my volume is now given by 5t squared plus 3t minus 2. And we're supposed to find the volume when t is 5. So when I sub inside 5 squared is 25. 3 times 5, you can write 15 straight away. So this will be 75 plus 15. Sorry, it's not 75, it's 125. 5 times 25 is 125 plus 15 minus 2. Answer 138. Alright. Number 7. Okay, this one is involving area. In a given diagram, the straight line 3y equals 4x minus 13 intersect the curve at point K. So you want to find the coordinate of point of intersection. Okay, I think we have to solve them simultaneously. Okay, but we should maybe name this as equation 1. So I will make x as a subject. I bring over x is now 2y squared plus 2. I call this equation 2. As I sub 2 in 1, 3y is now 4. 2y squared plus 2 minus 13. 8y squared plus 8 minus 13. 8y squared minus 3y minus 5 is now 0. I think we can factorize this. 8 times 5 is 40. So we should use, to get 3, I should just use 8 and 5. So 8 and 5. 8 should be negative, 5 should be positive. Y is negative 5 over 8, or Y is 1. But you can see from the graph here, point K is on the right hand side and is above the x-axis, so your Y value is more than 0, right? So we ignore this. We'll take Y equals to 1. Take Y equals 1, we sub inside equation 2. You can use equation 1 as well. So 2, 1 square plus 2, x is 4. Coordinate of 4 point K is just 4, 1. Alright, this is part A. Okay, but before you find the area of shaded region, so let's do some groundwork. We know that when you integrate, if you're going to find the area, you have to either integrate respect to y or respect to x. But you can see if I want to integrate respect to x, right, I need to move this down towards the x-axis and I need to make y as a subject. So your y will be x minus 2, you divide by 2, then you have to square it. And when we square it, we have to put a plus minus. So that's the thing. So sometimes a lot of people tend to, make a mistake because should be considered positive 1 or negative 1, yeah, if you're not sure. So what I would say is that if I see that if it's easier to make x as a subject, I will integrate respect to the x-axis instead, right? The y-axis instead, right? So now, if you can see from here, if I integrate the y-axis, we take this straight line, we move towards the y-axis, yeah? Move towards the y-axis. What do you see? You see a trapezium. And if you take a curve here, you move towards the y-axis, you get a curve like this. Okay, sorry, my curve looks a bit ugly. One more time. So it looks something like that. So we just have to subtract them, right? Okay, to get, oh, I think I messed up a little bit. Yeah, you can't see clearly, right? Yeah, the question shouldn't say area of shaded region. The question, I think the area of shaded region is supposed to be here, I think. Yeah, so not this part. They gave the wrong shaded region. Yeah. Okay. Otherwise, there's no point for them to give you the point intersection. You can just integrate directly, right? So anyway, now, because if you want the shaded region here, we can just integrate this. It has nothing to do with point intersection. I hope you know what I'm talking about, right? No point for us to integrate, okay? So anyhow, this will be area of trapezium. This is 1, because I know my y value is 1. This is 4. We have to find this. Now we know at x-axis y equals to 0. Okay, so what should we do? We should take this curve, put y equals to 0. Okay, should I say equation 2? This is equation 2 here. Okay, maybe I rewrite here. Y equals to 0. So your x is just 2. This is from equation 2. So this value here is 2. Okay, this is 2, 0. And also, this is from equation 2. From equation 1, when your y is 0, 4x minus 13 is also 0. X is 13 over 4. So this is 13 over 4, right? So this will be 13 over 4. Actually, I don't need the 2 here. I need 0 to 1. Yeah, I don't need this 2. Yeah, I think I don't need this 2. Don't bother finding this 2. Just find the y, the x-intercept of the straight line. So it's 4x minus 13 equals 0. X is 13 over 4. So, and we know this length from here to here is now 4. So your area of shaded region, the shaded region here, I'm referring to a shaded region here, will take half sum of parallel side. Your parallel sides should be 4 plus 13 over 4 times height is 1 minus integration 0 to 1 2y squared plus 2 dy. Okay, 4 times 4 is 16. 16 plus 13 is 29. So this is 29 over 4. Now the second one, when I integrate, I get 2y cubed over 3. This is 2y 0 to 1. This is 29 over 8 now. And when I sub 1 inside, I get 2 over 3 plus 2 minus 0. Okay, now this is actually 8 over 3. Okay, I just need to highlight this. I think the intent or the intention of the question is to find the shaded region, the black region. There is no point for us to find the point of intersection here if they ask us to find area of this shaded region, because the area of the pink color shaded region is actually 8 over 3. Yeah, guys, it's actually 8 over 3. And this is the answer given in the back of the textbook, right? Okay, but if you think that, okay, I just want to give what the answer wants, okay, so then you just forget about area trapezium, just find this area, then that's it, that's your answer. But if you want to, you know the purpose of the question is to find the shaded region, the black region. So we take 29 over 8 minus 8 over 3, you should get 23 over 24. Yeah, just use your calculator. So area is 23 over 24 square unit. All right, let's move on to next one. Okay, this one you have to use some brain. Okay, so yes, the diagram on the right shows a consumer demand for the demand curve dx, okay, and producer supply curve, demand and supply for economics. Okay, region M represent consumer surplus and represent producer surplus. Okay, so find the equilibrium point. So to find equilibrium point, basically we have to solve them simultaneously, right? The first equation is your dx, demand. Second equation is your supply, sx. So we just equate demand with supply. Okay, let us expand. X squared 8x plus 16, 3x squared 2x plus 4, rearrange 2x squared, bring over 12 plus 8 is, sorry, 2 plus 8 is 10. So 4 minus 16 is negative 12, divide by 2, and we can factorize this. Okay, so we should use 6 and 1 plus and minus x is 1 or negative 6. Okay, look at the diagram. X is on the right hand side, so x cannot be negative. Yeah, x has to be 1. When your x is 1, you can sub inside any equation. Maybe I sub inside my demand, which is x minus 4. So it's 1 minus 4 square root is 9. So your coordinate point P is just 1, 9. Okay, so that is the first part. All right, the second part, find the consumer surplus. Okay, the consumer surplus is given by the region M. So to find M, right, I think we can just, since they give us in terms of x, it's actually y in terms of x. So we can actually think this curve here, right, minus this rectangle to find the region M, right? And we know that this point we have to find the integration of this is not a problem, because we know the area should be, region M should be integration 0 to 1. Your function for the curve is x minus 4 square dx. But for the triangle, the rectangle, sorry, we need to find the area. This is 9 because it's given here 1 to 9. So I'm just going to use length times breadth, 9 times 1. So here I use composite function, x minus 4, increase the power by 1, 3, divide by 3, differentiate inside is actually 1. If you don't want to write, it's okay. 0 to 1, this is 9. Let's put 1 inside. 1 minus 4 is negative 3, negative 3 cubed is negative 27. Put 0 inside x is 0 minus 4, negative 4 cubed, negative 64. And from here, 64 minus 27 is 37 over 3. You minus 9, you get 10 over 3. Or you can write 3, 1 over 3, yeah, unit. Okay, I have a bit of problem. I don't have enough space for part C. Okay, so to find n, we need to take the rectangle and we minus the second curve here. Okay, my curve looks a bit ugly, sorry about that. Okay, let me just do one more time. This curve here, we're finding area under this curve here. So we'll draw a curve like that, so that when you subtract, you get shaded region N. not M, Nigeria, not Malaysia. So this area we know is 9, 1 times 9 earlier, right? But the curve is below now. The curve has a function 3x squared plus 2x plus 4 dx. The lower limit is 0, upper limit is 1. So this is 9. Okay, I better label this as n, right? Shaded region n. So when you integrate, this is x power 3 divided by 3, cancel the 3. X squared divided by 2, cancel it. This is 4x. Lower limit 0, upper limit 1. So if I put 1, this will all be 1. 0 is the easiest number to sub in because they are all going to be 0. So it's 9 minus 6. Yes, you get 3 square unit. Alright, moving on to number 9. Alright, so first you have to solve simultaneous equation to find the coordinate point P. So maybe I make one of them as a subject. I have 4x, this is part A, minus equals to 4 minus y squared. Leave it as equation 1. The second equation is 3y equals to 18 plus 2x. Maybe I rearrange it. I will just write 2x equals to 3y minus 18. I just times 2. You can use substitution or elimination, up to you. I will just take 1 equals 2. They are equals. So 4 minus y squared equals 6y minus 36. Y squared plus 6y minus 40 equals 0. What's the factor here? We should use 10 and 4 minus plus and minus, right? So y is now more than 0. You can see here the coordinate point P here. The y value is above the x-axis, so it's positive. So y has to be 4. So when you sub inside equation, any equation, equation 1, 4x is 4 minus 4 squared is 16. So this is negative 12. X should be negative 3. So point B is minus 3, 4. Alright, so this is part A. So for part B of finding area shaded region A, shaded region A, you can see it actually consists of a triangle like this, and then you have to plus the integration. So here I prefer to, again, I prefer to integrate respect to y instead of respect to x, because with respect to x we have to take the trapezium minus this integration, right? Respect to y, we have to take a triangle plus this integration here. I will do respect to y because I can see it's easier to make x as a subject than y as a subject. But if you choose to do the other way, can, but be mindful there's a plus minus when you square root, and you probably have to take a positive sign. Okay, anyhow, let's do this. I need to know the limit. Alright, so we know point P is minus 3, 4. That means the length from here to here is 3. The triangle, I know, is a bit too small. This is 3 here, right? And we also need to find, we know this is 4. Sorry, this point is 4, but we need to find, this is minus 3. We need to find the x-intercept. Now, we know the y-intercept. The y-axis, x is 0. So we take your equation 1, x is 0, 4 minus y squared is 0, y squared is 4, y is plus minus 2. Just take the positive 2, so this is 2. At the same time, for the second one, right, the second equation, y-axis x is 0, 6y minus 36 is 0, y is just 36, divided by 6, y is just 6, okay? So we know this is 6, so the height will be 2 here. This one we have to integrate from 2 to 4, okay? Okay, but if you integrate it, okay, let's just calculate area triangle first, one by one. Area triangle is just half times base times height. Base 2, height is 3, no problem. But when you integrate anything towards the y-axis and it's on the left-hand side of the y-axis, right? They are all negative because your x values are negative. So just be mindful of that. So you need to put a negative in front, right? Or you can put a modulus from 2 to 4. And let's make x as a subject. Look at this equation 1. X will be 4 minus y squared over 4, right? So because of my limited space, so I'm just going to squeeze in here. I'm just not going to rewrite, all right? So this will be 3 negative here. In fact, I like to take out the 4. Take out 1 over 4 is easier. When you integrate, this will be 4y. This is y cubed over 3, lower limit 2, upper limit 4. So keep the 3 here first, negative 1 over 4, put 4 inside. 4 times 4 is 16, 4 power 3 is 64 over 3, 4 times 2 is 8, and 2 power 3 is 8, divided by 3. You can just use your calculator. This will be 3 minus 2 over 3. You can write 8 over 3, yeah? And your answer is 5, 1 over 3. Now if you write in mixed number, it will be 5 over 3, 5 2 over 3, sorry. If you write in proper fraction, it's 17 over 3. Somehow for area volume, I like to use mixed number rather than improper fraction, because mixed number actually gives us a better idea. Like 5 over 3 means the value slightly more than 5, right? Okay, now for volume. Now volume generated with shaded region B is rotated 360 about the x-axis. So when you rotate about the x-axis, the shape that you're getting is like something like that, all right? So, and when you rotate about the x-axis, remember, the volume is pi y squared dx. So we need to make y squared as a subject. So y squared is 4 minus 4x now. So your volume will be integrate pi 4 minus 4x dx. Lower limit is negative 3, upper limit is 0. So we take 4 minus 4x, increase the power by 1, 2, divide by the increased power, differentiate inside, negative 4. I like to use composite function again as compared to integrating term by term, because it's easier. In fact, I'm thinking, guys, can I take out the 4? This is a bit annoying, right? Take out the 4, much easier. So this will be, if I take out the 4 and a pi, this is minus 3, 0, this is 1 minus x. Isn't it easier? And when you integrate, this will be 1 minus x squared over 2 negative 1 minus 3, 0, right? And 4 divided negative 2 is negative 2 pi. Here, put 0 inside, I get 1. Yeah, 1 minus 0 is just 1. 1 square is 1. Put negative 3 inside. 1 minus 3. 1 plus 3, yeah, is 4. 4 square is 16. So let us just write 16 here. All right, negative 16. 1 minus 16, negative 15. 15, negative 15 times negative 2, positive 30 pi unit cube. Yeah, the volume is in cube. All right, next question number 10. Yeah, we got a lot of question to go, right? Still quite a bit of question to go. All right, so in this question, we are finding first coordinate point P, R, and S. Okay, again, we have to solve simultaneous equation. Okay, wait, before I think about simultaneous equation. Oh, they are given, you're given point Q already. Oh, this is a line that touches the curve at one point. So this is a tangent. Oh, indeed, in this case, we have to use dy dx. Now, we know that maybe I make y as a subject. Y is now 4 minus x squared. So when I differentiate dy dx, I should get negative 2x. At point Q, your x is 1. Your gradient is negative 2. Now, this represents gradient of tangent. So, to form equation tangent, remember we use y minus y1. My y1 is 3. Gradient of tangent is negative 2. X minus x1. x1 is 1. So my y is minus 2x plus 2 plus 3. Y is minus 2x plus 5. Since my y-intercept is 5, yeah, my y-intercept is 5. So P is 0, 5. To find x-intercept, right? Okay. To find x-intercept, we know at x-axis y is 0, so I'm going to use y be 0. Let y be 0. I bring over x is 5 over 2, so r is 5 over 2, 0. Okay, I got P, I got r. Next, I want to find s. S is your y-intercept of this curve. So we know at y-axis, x is 0, y is just 4. So therefore, s is 0, 4. Okay, I hope you're okay with all these three. Quite easy. To find area shaded region, in this case, we have to move it down towards the x-axis because y is written as a subject, so it's easier to integrate y rather respect to x rather than respect to y. So to find the area shaded region, here I'll take a trapezium. This is a trapezium here. Then you minus this curve here. And we already know your P is 5, so this is 5 here. Q is 1, 3, so this is 3 here. The length is 1. For the curve, we just need to know that we have to integrate from 0 to 1. So for area trapezium, we just use half sum of parallel sides times height. Then a minus area of integration 0 to 1. My function is 4 minus x squared dx. So this is 4. When I integrate this, I get 4x minus x cubed over 3. Lower limit 0, upper limit 1. Let's put 1 inside. Get 4. This is 1 over 3. This will be 0. Answer is just 1 over 3. 4 minus 4, 0. Negative, negative 1. Negative times negative 1 over 3 is just positive 1 over 3. So this is your area. As for your volume, you are supposed to take the region bounded by the curve. Now when you say the region bounded by the curve, the y-axis and straight line parallel to x-axis. So we are talking about, let me rub this off, straight line parallel to x-axis that passes through Q. Parallel to x-axis passes through Q is this line, and this line is y equals to 3. Okay? Right? So you are taking the region bounded by the curve. This is your curve, right? Y-axis. Okay? Straight line parallel x-axis passes through point Q. So we are talking about this region here. Okay? Now this is a bit tricky. This is 1. So when you rotate 360 degree about the y-axis. So when you rotate about y-axis, the graph is supposed to look, the shape is supposed to look like this. Can you see that? Yeah. So you rotate, because originally the region is this. When you rotate, you view from the top. What do you see? It's like a thin line. Then when you go 360 degree, the bottom here should be a circle. The top is actually a smaller circle. They all smaller circle add up to get a shape like this. So we have to integrate pi x squared dy because you're rotating about the y-axis. Alright, now my lower limit will be 3, my upper limit will be 4 because I already know coordinate point S is 4. So let us sub inside, take out this 3 to 4. Your x squared is now 4. Make x squared as a subject from here. Can you see from here? So x squared is now 4 minus y. So let's sub in 4 minus y here, dy 3 to 4. So when you integrate, you get 4 minus y squared over 2. Differentiate is negative 1 here, right? So lower limit is 3, upper limit is 4. Let's take this out. Okay, put 4 inside. 4 minus 4 is 0. Put 3 inside. 4 minus 1 is 1. Answer is pi over 2 unit cube. All right. Moving on. Question number 11. So here a curve has a gradient function f prime x equals to bx squared plus 6x, so p is a constant, and this line is a tangent to the curve. So if you want to understand how it looks like, the curve probably look like this. So this is your straight line, y equals 24x minus 30. Okay, so I need to find values of p and q. Okay, you already know your gradient function, right? So to find equation of the curve fx, so you can write y, we basically just integrate. Okay, but before that, because I want to find p, right? I want to find p first. So maybe I just sub inside, because we know at this point the coordinate here is 2q. At this point, your gradient is 24, isn't it? Yeah, your dy dx or your f prime x, maybe I write f prime x here, yeah, because the equation of this line has a gradient of 24. So your f prime x must be 24 when your x is 2. So I'm going to sub inside my gradient function. So this is 2 square, 6 times 2 equals 24. 6 times 2 is 12, 24 minus 12 is still 12. 2 squared is 4, p is 12 divided by 4, p is 3. But I know you look at this and wonder where's the integration part. This looks more differentiation than integration. Yeah, in fact it is because you don't need to integrate. I think the question should not give you this equation. It should just give you the gradient, because in order to find your y value, we should integrate this to find your y. But since this is a tangent, this is not a line parallel. If they say it's parallel, then you cannot sub inside. What I'm saying is this, let's say this line is your tangent, and there's another line parallel to your tangent. Yeah, and let's say this line has a gradient of 24x minus 30. Can we sub your coordinate 2q inside here? Cannot, because it's not parallel. But this, I mean, it's not on the line. It doesn't pass through. The point doesn't lie on the line. But in this case, they already given us. They already say that this is a tangent. So I think the question could be better. Yeah, they could say it's parallel instead. So you can find a different coordinate q. So since we know this, right? So we just sub in 2 and q. So your y is now q. Your x is 24. Times 2, your x is 2, sorry, 24 times 2, you minus 30, q is 40, 48 minus 30 is 18, yeah? So there is no integration, it's just differentiation. Alright, let's look at question number 13. Okay, this one looks a bit tricky. Diagram on the right show the curve y equals to, number 12, sorry, I say wrongly, y squared equals to x plus 28 intersect the curve at point K. Calculate the area shaded region P. Alright, if I know point K, I can just draw a line here. I know this is -3, this is 5. To find shaded region P, it actually consists of a curve like this plus another curve like that, right? We know this is going to be -3, right? And we have to integrate two separate functions, right? But we need to find the x-intercept. Now we know at the x-axis, your y is 0, so the first equation is x plus 28 equals 0, x is -28, so this is -28. The second equation is x squared minus 4, I let it be 0, x squared is 4, x is plus minus 2, but we'll take the -2 because we know it's on the left hand side. Okay, you can write plus minus 2. Okay, so I know the limit now. Can now integrate. So my area consists of the first curve here. It's given by, if I make x as a subject, y as a subject, I think we need to put a square root, right? So y as a subject, you got to put a square root here, and it's a positive square root, not negative square root, because it's above the x-axis. So we can put x plus 18 power half. Lower limit is -28, upper limit is -3. The second one, if you integrate, before integrate, we know the function is x squared minus 4 dx. Lower limit is -3, upper limit is -2. So when I integrate, I have to, the first one I have to use composite function, increase the power by 1, divide by the increased power, differentiate inside. Lower limit is -28, upper limit is -3. Second one is x cubed over 3. This is 4x minus 2 minus 3 minus 2. Okay, let's sub in. Okay, again, I like to do it a bit quicker. I like to take this 2 over 3 out. Now, when you divide by 3 over 2, it's the same as multiplying 2 over 3. Put -3 inside your x here. 18 minus 3 is 18 minus, okay. I'm going to put -3 inside. Well, 28, sorry, I think I wrote this is 28. Sorry, not 18 or 28. Yeah, this is 28. I must have seen it wrongly. So 28 minus 3 is 25. 25 when you, okay, let me just write this. 3 over 2. If I put 28, I'll get 0 here. Negative 2 power 3 is negative 8 over 3. Negative 4 times negative 2 is positive 8. This is minus 27 over 3. You can write negative 9, and this is 12. Right. Okay, so if you square root of 25, you get 5. 5 power 3 is 20. 5 power 3 is 125. 125 times 2 is 250 over 3. Okay, maybe I write this as negative 9, easier for me to count mentally. Negative 9. So this will be minus 8. 8 minus 3, negative 3, negative 5. Just 5. 5 minus 8 over 3, 7 over 3. So, okay. So it's 257 over 3. And what is 257 over 3? You can write this as 85 over 3. Okay. B. I need to find the volume when shaded region Q is rotated 360 by y-axis. Okay, when you rotate by y-axis, you need to make x squared a subject. So it's x squared equals to y plus 4. Now, we know this, your y-intercept is negative 4. I think so it's quite clear cut, right? So we have to integrate from minus 4 to 10. So volume is given by integration of pi x squared dy minus 4 to 10. So take out pi. I like to use composite function. Increase the power by 1. Divide by the increased power. Differentiate inside the bracket minus 4 to 10. So when you put 10 inside, 10 plus 4 is 14. 14 squared. You can write 196. 196. If I put negative 4 inside, I get 0. 196 divided by 2 is 98. Answer 98 pi. Oh, this is long. Question 13. Next one. I'm supposed to find the value of C. Okay, the coordinate point A. So we know that we can just sub in, right? Your equation here is y equals 2x squared minus 3x plus c. Okay, when x equals to 5, your y is 33. So I put 5, 33. 33 equals to 5 squared is 25. This is 3 times 5 plus c. 25 minus 25 times 2 is 15. 50 minus 15 is 35. So 33 minus 35, c is negative 2. My equation will therefore be this. Okay, next, I want to find the coordinate point A. A will be my x-intercept. So I know at x-axis my y is 0. Just double bracket factorize to 1 minus plus. So x is negative 1 over 2 and 2. We know x can't be negative. Yeah, it's on the right hand side here. So x coordinates 2. A is 2, 0. Alright. Okay, I think I need to reserve some space for area and volume. It's quite long on this question. Part B. Okay, how do you calculate area of shaded region? So we have to break it up to two parts. The first part is 0 to 2. The curve is 2x squared minus 3x minus 2 dx. This part is below the x-axis, right? You can see here, below the x-axis, your y value is negative. So when you integrate, it's going to be negative. So we need to put a negative in front, or you can put a modulus to balance it out, to make it positive. Okay, then you plus with 2 to 3, 2 to 5, but this is 5, right? 2 to 5 of 2x squared minus 3x minus 2 dx. Okay, for me, I will just put integrate 1 by 1. Now this is 3 over 3, x squared over 2, integrate 2 is 2x, 0, 2, and you have to copy the same thing. This is not difficult, just copy only, right? Let us put inside, okay, a bit tedious. 2 power 3 is 8, 8 times 2 is 16, 2 squared is 4, 4 divided by 2 is 2, 2 times 3 is 6, 2 times 2 is 4 here, this is minus 0. Put 5 inside, is 125 over 3, 5 squared is 25, 25 times 3 is 75 over 2, 5 times 2 is 10. Okay, this part you can just copy because it's the same. just copy from the first part over here. It's the same thing, right? Okay, now you need to use a calculator. This part here I cannot help you. You need to count number one, it's too slow. Just use a calculator. The answer is going to be negative 14/3. You notice there's a negative in front to make it positive. The second part, I'll just count one shot. I'll get 81/2. You should get to 71/6 or 45/1/6. Okay. Now, how about volume? Okay, find the volume when the region bounded by the curve and the x-axis is rotated 380 about the y-axis. Okay, the x-axis, sorry. So this region here, yeah, bounded by this and the x-axis is only this part here. It's a very small part, yeah. When you rotate about the y-axis, the x-axis, it should look like this. Okay, I know you don't have to draw. It's not important. The shape is not important. More important thing is you know how to integrate. Okay, but I will have a problem with space because this question here is very long. So you already know the function, right? So okay, let me write out function, then I'm going to move this up. Okay, so number one, you know we have to integrate pi x squared y squared dx. So my y is 2x squared minus 3x minus 2. Then you got to square it dx. And another thing is that usually they don't ask this, but this time they say 180. 180 means you don't do a complete solid. Yeah, you don't normally we rotate 360. 360, then this is the function, the integration part. But I only rotate 180, so I need to halve it here. And the limit is now from 0 to 2. Okay, now let's move this up a little bit. Move this up a bit. Okay, the hard part about this is that how do you integrate this? Remember, the composite function method, if you want to use this formula is only valid if whatever inside the bracket is linear. If it's non-linear, it cannot work, right? So we have no choice but to expand the bracket. I know this bracket looks really hard to expand. I have a better idea. We treat this as your A, this as your B. So when you expand, it looks like this. This is my A squared plus 2AB. 2AB would be, this is my A again, this is my B, and my B squared. It's easier to do it one by one like this. Okay, sorry, I still need to expand this part here. This will be 4x power 4. 2 times 2 is 4. 4 times 3 is 12. X power 3. Negative 3 squared. 3x squared is 9x squared. This one is negative 4 times in. Negative 4 times 2, negative 8x squared. And positive 12x and plus 4. Suddenly it looks easier, right? Okay, but I still can simplify this, right? Yeah, you notice the 8 and 9, you can put it together. Okay, let's just simplify further. 0 to 2, 4x4 minus 12x cubed plus x squared plus 12x plus 4 dx. Okay, move this up a little bit more. Right, okay. Now this will be then 4x power 5 over 5. Now x power 4, 12 divided by 4, left with 3. This is x power 3 over 3. 12 divided by 2 is 6, 6x squared. This is 4x, lower limit 0, upper limit 2. Okay, so now let us substitute 2 inside. Yeah, 2 power 3 is 32. This big number, 32. Yeah, you times 4, 1, 2, 8 over 5. 2 power 4 is 16. 16 times 3 is 48. 2 power 3 is 8. 2 power 2 is 4. 4 times 6 is 24. 2 times 4 is just 8. Okay, you can just use your calculator. Just too long to do all this thing. I got 92 over 15 pi, or you can change to 6 2 over 15 pi, right? I know this question is a bit long, a bit tedious. Okay, let's move on to 14. Question 14. I think we got 2 more. All right. Diagram on the right shows a cross section of a container, which is a parabolic inner curved surface area. Alright, this is quite similar to one of the past year, SPM 2014 if I'm not mistaken. Right, so your y equals to ax squared. Alright, I need to start off by labeling this. This is your y, this is your x, it will pass through the origin. So this point, if I take 60 and divide by 2, the length here is 30. So this is 30, 30. So we start by substituting 30, 30 inside. So we can find a 30 square is 9. Can cancel, no need to square it, cancel 30. 30 is 1 over 30. So my y is now 1 over 30x squared. Alright, so you want to find the mass of the rice in kgs can be stored. They give us the rice density. So that means we need to find the volume. Yeah, remember density is mass over volume. We have to find volume first. So and we need to rotate 360 degrees because the volume that we have is over here, right? We should integrate from 0 to 30 here. So we need to make x squared as a subject. So it's 30y. My volume will be integration of 30y dy. Remember to put a pi. Yeah, we need to put a pi here. Lower limit is 0. My upper limit is 30. Okay, so this is maybe I'll just write pi here. This is 15y squared, the 0, 30. Okay, let us put 30 inside. 30 square, 900 minus 0. Okay, this will give us 13500 pi cm cube. All right, so there's a volume, but it's not the mass yet. Now we know mass is divided by volume. 130 pi gives us the density 1.182. All right, so you just take your calculator. 13500 times pi. The question never say use 3.142. I think you can just use your calculator pi. You will get the mass as 50.13. This is 50130 gram, but you want kg, right? So yeah, when you change your kg, it's 50.13 kg. All right, next one and the last one. All right, Mr. Razak plans to build a swimming pool at his residence. So the swimming pool has a uniform depth of 1.2 meter. The rate of flow of water dv dt is given. So we want to find the volume. So we know we have to integrate 3d square, integrate your dv dt to find your volume v. This d power 3 divided by 3 cancel out. This will be 7d squared plus c. Okay, now we know initially, the boundary condition, when t is 0, the time you start the clock, the volume of the water is 0. So therefore your c is just 0. So the volume function is now given by this. Alright, so he said it takes 5 hours to fill in the pool. So that means d equals to 5, v equals to 5 power 3, 125. 7 times 25 here. So this will give us 300 meter cube. Alright, part E. So no problem, found the volume. Second, Mr. Razak want to paint the base of the pool with the blue paint. Right, the cost of painting is 5 ringgit per meter cube, so per meter square. So he allocates 1,000 ringgit. Will it be enough? Right? Okay, so you know the base, right? We know the volume already, so we know it is they say it has a uniform depth down. Now it doesn't matter lah, we just do a rough sketch like a cube here, right? But we know the depth is 1.2. We know the volume, and we know this is your base, right? So let's find out the base area. We know base area times height that gives us the volume 300. A is 250 square meter. Now if it costs 5 ringgit per square meter, so what's your total cost now? 5 ringgit times 250 is 1,250. Now he allocates 1,000 ringgit, so this is more than RM 1,000. So does he have enough? Yeah, so we can say No is not enough. All right, we are done, right? Okay, before we go, just so you know, if you are interested, we have lots of material, exercises, learning module that I've written over the last 20 years. All right, so you have topic of practice, the notes and tutorials, step-by-step work, and past year question, as well as drill practice available. You can, if you're interested, you can contact us or just visit our website, like us on Facebook, Instagram, or even WhatsApp us. Right? Thank you for watching. I'll see you guys in the next video.